Welcome to ECE 1220 at the University of Utah. Today we will be learning the node voltage method, also known as nodal analysis. First, we will learn how to label node variables in a circuit, and then use that to determine how many equations we need to solve the circuit. And then we'll learn how to write equations to represent each node in the circuit. And finally, we'll learn to solve that system of equations to solve for the nodal voltages. Today we'll only do ones with a single unknown nodal voltage, but we'll continue in other lectures to move on to more complicated circuits. So previously, when we tried to solve a circuit like this, we used our various principles that we've learned, like Ohm's law and KVL and KCL, to solve the circuit. Let's see if we can use any of them in this case. So we might try using Ohm's law on this resistor, for example, but notice that we only know the resistance. We don't know the voltage across it or the current through it, and we need two of the three to use Ohm's law. Maybe we try to use KCL at this intersection right here. We know this current, but we don't know this one or that one. So again, we don't know two out of the three, so we can't use KCL. And finally, I might try using KVL around a loop like this one. So I know this device's voltage, but I don't know the voltage here or the voltage here. So again, two of the three I don't know, so therefore I can't apply the equation. So it turns out we're going to have to apply a combination of these and then solve the system to be able to solve this circuit. And we're going to learn a general procedure to do that on any circuit. So the procedure for nodal analysis starts with labeling all the nodes. So choose a ground. I'll choose the bottom here. And then label all the other nodes either with a known voltage or a variable. So in this case, if we trace through the 5-volt source, we know the nodal voltage up here must be 5 volts compared to ground. Then we have one other node in this circuit, this one right here. And this one we do not know the voltage of right now. So we will label it maybe VA. And in this case, we can relate VA, the nodal voltage, to the voltage difference V1, because VA minus ground, which is 0, better be equal to the voltage difference, V1. So then VA must be equal to V1. And then finally, it tells us to label current. So I will label current here. Again, order of my arrows doesn't matter as long as I'm consistent. So I'm just choosing a direction. I'll make this I0, and then I'll make this one I1. So it's important to make sure that every resistor in the circuit has a current label. Okay. So then the next step will be using those current labels at the unknown node, we will apply KCL. So in that case, our unknown node is V1 up here. And so we can write an equation relating I0, I1, and the 1 milliamp source. So in this case, we have I0 is going into the intersection, and coming out is 1 milliamp and I1. Now the next step is we're going to use Ohm's law to replace those currents with V over R expressions, because Ohm's law tells us that I is equal to V over R, where this is a voltage difference. And so then to get from two nodal voltages, I subtract the one on the negative side from the one on the positive side to get the voltage difference. So in this case, for the 1 kilo ohm resistor, to replace the I0, I have 5 volts on this side, and I have V1 on this side, and based on the direction of the current arrow, right, in a resistor, current always flows into the positive side. That's the passive sign convention we learned in Unit 1. So that means I will do 5 minus V1 all over 1 kilo ohm is equal to 1 milliamp. That just stays. And then I replace the I1 using a similar system. So this arrow is indeed pointing into the positive side there, And in this case, V1 is the voltage across the resistor, and the resistance is 1 kiloohms. So now we've created an equation with one unknown. So we have one equation and one unknown, and therefore we can just solve that using algebra to get V1. So what's the best way to go about solving this by hand? Personally, I like to get rid of the denominator by multiplying by the least common multiple. In this case, 1 kiloohm or 1,000 is the least common multiple. And so that's going to cancel with each of these, and then this will also cancel with the milli there, leaving me with just 5 minus V1 is equal to 1 plus V1. And then my final steps would be I subtract this to the other side, and I add this to the other side. So I have 2, oops, I wrote V2 instead of V1. So I have 2 V1 on this side, and I have 4 on that side. So V1 must be equal to 2 volts. And with that, I think you are ready to do the worksheet. You feel free to watch this video again if you need to watch the process once more. And if you noticed, I also on the slides show all the math calculations there, nice and neat in TypeScript for you.